Okay, before we commence, can I please get a confirmation that you guys can hear me as well as in the YouTube chat for those of you who are watching there? Please, can you confirm that you can hear me? Sorry, chat is not open. Let me open it and then confirm that you guys can hear me, see me, and see my screen, please, and we can continue. Anyone? Any soul? Can you guys hear me? Please confirm you guys can hear me, see me. Everything is cool. Everything is working fine. Okay, perfect. Thank you. Thank you. Okay, so just to note, guys, okay, assalamu alaikum and good morning. Welcome back, guys, to grade 11 maths by Inspired Teens, where today's lesson we are going to be continuing with exponents and surds. Okay, please note that for those of you who are in here, for those of you who join every week, for those of you whose friends join every week, the Zoom link is always going to be found in the group description. In the group description, there's the Zoom link, there's the Google Drive link that you can access. You don't have to ask me for it. It's always there. You can use the same link every week. Okay. The YouTube link, the YouTube live link, that's the only thing that I send every week that you have to use. And the YouTube playlist link as well. Okay. For all the old videos that if you want to rewatch. Okay, that's the first thing. Second thing, just a reminder, if you guys do have any questions, please ask them in the chat, the Q&A, or the YouTube chat, if for anyone who is on YouTube, right? That's the second thing. The third thing is the Google Drive, which again, the link is found in the description. The Google Drive, I have uploaded a document. Many of you have been asking for a timetable. Okay, I cannot give you a timetable because it's difficult to judge when we are going to finish certain topics. Okay, however, I did put a document there that shows you the order in which I'll be covering topics from term 1 to term 4, so that you are aware that when we finish a certain topic, what topic we are going to be doing next. So please have a look at that document in the Google Drive. Okay, cool. So let us continue. So last week we did rules of exponents. Okay, we started it off. I think we were finishing the previous topic, and then we started on rules of exponents, where we discussed the rules of exponents. Okay, so I hope you had a time to go through them, revise, and you made sure that you understand these rules of exponents. Now we're going to proceed. Okay, so we went through 1, 2, 3, 4, 5, 6, 7 rules of exponents. We went through simplifying surds as well. So how do you simplify surds? You have to write the number inside of the surd as a product with a perfect square, and you simplify accordingly. Okay, so before we get to continuing surds, we're going to discuss fractional exponent. For fractional exponent is a simple concept. It's a fraction inside of an exponent, right? But how does that work? So basically, okay, when we have a surd, just say I have a to the power of 2 or a to the power of 3. Just say I'm taking the square root or the second root of a to the power of 3. I can get rid of the surd. Okay, how can I get rid of the surd? Let's do this. Okay, I can get rid of the surd. How do I get rid of the surd? I can write it with the same base of a, and now I'm going to write an exponent. Okay, how do I write that exponent? I take these values. Okay, I take the values of 6 and I take the values 3 and 6. So the exponent of the term inside of the surd becomes a numerator, and the number outside of the surd, this is not supposed to be 6, sorry, this is meant to be 2. So I'm taking the square root. Okay, remember, if nothing is written, if there's nothing written, we always assume that it's 2. Okay, it's the square root. Okay, so I don't even have to write the 2 there, but let's just put the 2 there. If it's not there, assume that it's the square root, which is 2. And that the root value becomes the denominator of our exponent. Okay, so in that case, yes, this simplifies to a to 3 over 2. Let's practice another example. So if I have square root c, okay, c to the power of 6, I'm taking the cube root of c to the power of 6, because I'm taking the 3 is on the outside. So obviously, if there's a 3 on the outside, that's cube root. Okay. So I'm taking the cube root of c to the power of 6. I can simplify this by writing same base. Now remember, my exponent becomes a fraction. The exponent of the term inside of the surd becomes a numerator. And which root am I taking? The third root. The number outside of the surd becomes the denominator. That becomes 6 over 3. So this therefore simplifies. This is the division. It simplifies to c as c to the power of 6 over 3 is 2. So it becomes c squared. Okay. So the cube root of c to the power of 6 actually simplifies to c squared. Okay. So I hope that makes sense. Let's move on to rules of surd. So we're going to start on the first one again. Okay, so we have square root a times square root b is equal to square root of a times b. So that's simple. All right. So if you want to talk backwards, again, you're going to have square root. It's like the example we were doing, right, with simplifying surds. If I have square root 80, right, if I remember correctly, we said that square root 80, so remember backwards, so square root a times square root b is square root a times b. So in this case, 80 could be written as, sorry, square root 80 could be written as square root, if I'm not mistaken. Okay, let's not choose 80. Okay, let's not choose, okay, it doesn't really matter. Square root 16 times 5, I haven't changed the value, 16 times 5 inside is still 80, and then simplify to square root 16 times square root 5. You can take it out and write it in separate surds. Obviously, then this then simplifies to 4 and becomes 4 root 5, but we just can leave it there for that specific example. Let's look at this guy. If I have square root a over square root b, I can write it all in one square root and write the fraction inside as a over b. Okay. Now we talk about number 3. Okay. So with number 3, square root a plus square root b, this is not simplifiable. Okay. This is not equal to, can you see the not equal to? That's important, right? This is not equal to square root of a plus b inside of one surd. You cannot do that. Okay. This cannot be simplified. Okay. So you're either going to simplify the surd itself or do something else, but you cannot do that. You cannot say that square root a plus square root b is equal to square root a plus b in one surd. It doesn't work. That only works with multiplication and division. Okay. So squaring a binomial, okay, squaring a binomial with a surd, we're just going to do a quick example. So remember, squaring a binomial, if you have a plus b squared, this becomes a squared plus 2 times a times b plus b squared. A squared plus 2 times a times b plus b squared. Okay. And if we're going to do the same thing here, remember, this is my a, this is b. Okay, that's plus. So yeah, basically I opened it up. Okay, I wrote the bracket twice. Alternatively, we can just take the shortcut, which is what I'm going to do. Okay, and remember my a and b values are there. A is a, b is actually square root b. Okay, maybe let's change the numbers to make it a bit less confusing. Or the values, let's make this q plus, no, that's the same thing, c. Q plus square root c, q plus square root c. So remember, q is acting as our a, square root c is acting as our b. So I'm going to square a, because remember this is the shortcut. So a squared, a is a, sorry, a is q, q squared, plus 2 into a, which is q, b is square root c, plus b squared, it's square root c squared. Okay, notice I put brackets whenever I'm substituting. Then I simplify this, becomes q squared plus, when you have a surd, when you have a square root, you can treat it like another variable. It actually becomes 2q square root c. Okay, plus square root squared is cancelled, so just plus c. So that's the most simplified version of that, just showing you how to square a binomial with a surd. Okay, and that's basically our rules of surds. let's move on. So before we utilize our rules of surds, okay, we are going to learn just a quick thing that's important for your exam. It's a few questions. They ask some questions, okay, where they basically want you to solve for x. And under the solve for x, you're going to have maybe your trinomials. Okay, you might have your simultaneous equations. And you're also going to have the surd equations, which you solve by essentially squaring both sides. Okay, so we're not going to complicate it. Here we have square root 8 plus 28, x plus 28 is equal to 2 minus x. So how do we solve this? We need to get rid of the surd. How do we get rid of the surd? By squaring it. When you square surd, that square cancels out the surd. And here I'm just left with x plus 28 because the surd disappeared. Here, on the other hand, I am squaring a binomial. 2 minus x is the binomial, and I'm squaring it. So I can follow the shortcut, or you can, if you guys prefer, let me do the long one this time. 2 minus x, and then what? And then distribute. So I have x plus 28. I'm going to do first, which is 4. Outer, which is negative 2x. Inner, which is negative 2x. And last, which is plus x squared. Okay. So my x squared is positive on the right. So actually, I want to take everything over to the right side. I'm going to have, let's just see. So I want to take everything over to that side. I'm going to left with 0 on the left. 4 minus 2x plus x squared minus x. Where am I getting minus x from? Here. Minus 28. Where am I getting minus 28 from? There. Okay, I'm just taking it over to the other side. So 0 is equal to, let's simplify like terms, 4 and negative 28, negative 2x, negative x, and x squared. So we have x squared minus 5x minus 24 is equal to 0. I can rewrite this as x squared minus 5x minus 24 is equal to 0. And it's no difference, right? I'm just writing it one on the left, one on the right. I'm not taking it over. I'm just swapping the 0 and whatever's on the left. Okay. Sorry. Let's move this down so we have space. Let's continue. Okay. So now I need to trinomial factorize. Okay, but the main part is squaring both sides, and that's done. X and x, minus and plus, 6 and 4, 8 and 3. I want a negative 8 and positive 3. So x is either equal to 8 or x is equal to negative 3. Done. So that's how you solve these type of questions. So this one, even for instance, let's see. Okay, you guys can do number 3. Let me do number 2. And number 4, we can come back to. So what you want to do for this one is you want to leave the surd completely alone. So let's just do that step by step. So first, I'm going to get rid of the plus 2. I have x plus 6. It's going to be equal to x. When I take that over, it becomes x minus 2. How do I get rid of the 2? I take it over. So currently, the 2 is in multiplication with the surd. So how do I take that over? Division. X plus 6 is equal to x minus 2 over 2. Now that I have my surd alone, I can square both sides. That surd cancels out with the square. I'm left with, on the left-hand side, x plus 6. Now, on the right-hand side, I have a fraction, okay? So how do I square a fraction? Simple. Or how do I simplify a fraction with an exponent? Same thing. You're just basically going to multiply the numerator and the denominator separately by the exponent. So on top, I'm going to have x minus 2 squared. And at the bottom, I'm going to have 2 squared, which is basically Okay, let's just write it as 2 squared. Now let's simplify. So x plus 6 is equal to, on top, it's a squaring a binomial. So you can write it out, x minus 2, and simplify. I'm going to just take the shortcut. X squared minus 4x plus 4 over 4. Now, what I could do is the 4 on the right-hand side is in division. So I could take it over as multiplication with everything that's on the left side. And that's exactly what I'm going to do. So since the squared is positive on the right, I'm going to try and take everything to the right because I always want my square term to be positive. When I distribute this, I get 4x plus 24 is equal to x squared minus 4x plus 4. So I'm going to leave everything. I'm going to take these over and I'm left with 0. X squared minus 4x plus 4 minus 4x minus 22. Where did I get these two from? Minus 4x is from there. Plus 24 becomes minus 24. So 0 is equal to x squared. Let's do like terms, x and constants. So x squared minus 8x minus 20. Okay, again, I can swap these if I really want, because it doesn't matter. That makes more sense. And I can trinomial factorize. X and x minus 10 plus 2. Okay, solved for x. Okay, so that's simply just squaring both sides, right? So now let's move on, right, from doing this. So this you have to know as well, right? Just surd equations. Basically, when you have a surd on either side of the equations, you need to square both sides and so on and so forth, right? Let's move on to simplifying surds, okay? So simplifying surds we learned. Let's answer questions without a calculator, just simplifying the surds. Okay, so if you put this entire thing in your calculator, it's going to give you one final answer, but this is without using a calculator. So if they have to answer, so if you have to know it, then we are aware of how to simplify surds, so we can take it from there, right? So let's look at 50. How can we simplify 50? For the perfect square, I can multiply 50 by 25. How do you factorize if you have a negative x? Okay, there is a way of factorizing, but you really don't have to. Just say if you have negative x squared plus 3x minus 4, this doesn't make sense. I don't think it does. It's equal to 0. Don't ever factorize with this negative. It's confusing. What you need to do is multiply both sides by negative. So again, you're multiplying both sides by the same thing. You're not changing the value of the equation. But then when you multiply this out, you're going to get positive x squared minus 3x plus 4x is still equal to 0. So basically change every sign. 50 can be written as 25 times q. 25 is a perfect square. Plus 3. Can we simplify 18? I think we might be able to. 1, 4, 9. All right, 9. 9 times 2. Minus square root 98. What's a perfect square that can go into 98? After square root 98, we get 7. We try 2, maybe 4. No. Well, great, perfect. Thank you for that. 49 times 2. Okay, so I'm writing them as products with perfect squares. So this is going to be equal to, remember, we don't have to go through that whole long step. What I can do directly is, if I'm taking a number out of a surd, I need to square root it. So it becomes 5 square root 2 plus. If I'm taking a number out of a surd, I need to square root it. It becomes 3 times 3 square root 2 minus, if I'm taking a number out of a surd, I need to square root it. 7 times square root 2. Now I simplify, I have 5 root 2 plus 9 root 2 minus 7 root 2. So now I have like terms. You can treat your surd like a variable actually. And basically 5 plus 9 is 14, 14 minus 7 is 7. My final answer is 7 root 2. Okay, this example you guys can do on your own, right? Okay, let's do it since we did fractional exponents. Okay, so let's talk about this, right? I want to take the 5th root of 81. Now, it's not easy to take the 5th root of 81, but I know that first I can simplify surds, number one. Number two is I can write what's the best way if I take the first root? Okay, let's just take it. I can write 81 as 9 squared. Oh, yeah, that's perfect. So the 5th root of 9 squared. Okay. Then the 4th root of 27. So what you can do is take your calculator, put 27 equals, and then do shift fact. We've learned shift fact, right? I think at this point we did learn shift fact. But on your calculator, you basically can, there's a fact button, which is the third, on the 3rd row, the 2nd column, 3rd row, 2nd column, it's where B is, if you have this gray, normal gray Casio calculator. And you just have to press shift and activate fact. It basically writes it as a product, or it's prime factors, I think. Okay, so we can write 27 as 3 cubed all over the 5th root of what's next? 9 can be written as 3 squared times square root 3, which is not simplifiable. Let's simplify further. Now I'm going to be using the fractional exponent law. So this becomes 9 to the power of 2 over 5. Okay. Times 3 to the power of 3 over 4. Okay. Over 3 to the power of 2 over 5 times root 3. Root 3 can be written as, like, let's look at root 3, right? The power inside is 1. The power outside is 2. So it can be written as 3 to the half. So that's how I'm going to write it. So when I'm doing everything, I'm noticing that one thing is off. Okay. And that's my 9. All my bases are in terms of 3 except 9. 9 is obviously in terms of 9. So I can actually write 9 as 3 to the power of 3 to the power of 2 over 5 and then multiply. All right. So 3 to the power of, 3 to the power of 2 is 9. And then multiply. So basically I get 3 to the power of 6 over 5. So I can do that. That's one way of doing it. Alternatively, you can go directly from 81 to 3 to the power of 4. I erase the 3 and put a 2. I mean, I erase the 3 and put a 3 again. Thank you for that. Okay, so now I can simplify. I can add the ones on top. So 3 to the, so you can either add or do the thing is, or you can even work with these. Basically, what we can do is we can say 3 to the 4 over 5 plus, okay, so I can, because the same bases multiplied, I can add my exponents, plus 3 over 4 divided by 3 to the 2 over 5 times a half. Sorry, you have to add them. Okay, you can do the fractional exponent, like you can do these on your calculator. Like in grade 11, they're not going to ask you, they're going to test you on whether you can add fractions. Okay, so you can probably use your calculator for that. But basically, it's going to be, let me get 20, it's going to be times 4, 16 plus 15. Okay, I'm just going to use my calculator. 4, 5 plus 3 over 4. 3 to the 31 over 20 over 2 over 5 plus 1 over 2. 3 to the 9 over 10. And then these are same bases in division. So 3 to the 31 over 20 minus 9 over 10. And then you get this is 3 to the power of 13 over 20. I think that's correct. If there's any issues, please let me know. Probably a quicker way to do it if you work with these two first and then work with these two and whatever. But like, I mean, this still works. Okay, you're basically just simplifying, utilizing the laws of exponents. So as you can see, you have to know the laws of exponents pretty well, like very, very well, if you want to answer this question. Okay, so we are basically like done with the theory. Okay, so now we're going to do some hard examples. Or just some general examples anyway. Okay, let's look at this example, which is terrifying to say the least. 1 second. Two point 1.1. Okay, so again, we're using laws of exponents and such, right? So we need not forget those. Now, firstly, what we can do is, okay, we can get rid of our fraction by doing what? By taking these to the top. So how do you take something to the top? You make it a negative exponent, if you remember from last week. So basically, I'm going to take it to the top and it's going to become negative n minus 1 times 3 to the negative n plus 1. All of this to the power of 1 over n. Thereafter, I basically have 3 to the negative n plus 1 times 3 to the negative n plus 1. Negative n minus 1. To the power of 1 over n. Now I can simplify what's inside because I have the same bases in multiplication. So remember, I can make it 3 to the, I can add them. So 3 to the negative n plus 1 plus minus n minus 1 all to the power of 1 over n. Then when I simplify, I get 3 to the negative n. That gives me negative 2n. 1 minus 1 cancel. I'm left with 3 to the negative 2n to the power of 1 over n. Now I need to simplify this. Remember, this is a power to a power. So it's 3 to the negative 2n times 1 over n. And the negative 2n can be seen as negative 2n over 1. How do you multiply fractions in a straight line? It becomes negative 3 to the negative 2n over n. N and n cancel. You're left with 3 to the negative 2, which is basically 1 over 9. Okay, so it's a scary looking question, but when we take it step by step, it's not that scary. Okay, I'm just trying to think. Let's see how far we get. We're either going to finish this lesson off with just examples. Alternatively, we might do what we might do. Let's start with trig. I don't know. Let's see. Okay. Let's look at something like this. Two ways of solving it. So, (2.2) 3 to the 2 minus x plus 8 is equal to 3 to the x. Whenever you see something like this, you always want to split it into its components. 3 to the 2 times 3 to the negative 1. Remember, we went through this, negative x, sorry. This is basically like saying 2 plus minus x. All right, so when you add them, when they added in the numerator, that means they came from multiplication. So I can just say multiplied by negative x. Plus, sorry, this is 3. Plus 8 is equal to 3 to the x. Okay. So now, what I can do from here is I'm going to simplify this. Firstly, I'm going to take this to the bottom. So 3 squared over 3 to the x plus 8 is equal to 3 to the x. 3 squared, I'm going to simplify to 9. So 9 over 3 to the x plus 8 gives us 3 to the x. We can't take a common factor. I thought we were going to be able to take a common factor. Okay, nature of roots. I think we've covered nature of roots. Someone just confirm. I think we've covered the nature of roots in a previous lesson, so you can rewatch that lesson. Okay, alternatively, what I could do is here, now I have to get the denominators the same. So in this case, the LCD is actually 3 to the x. So how do I get there? I multiply it by 1, so that remains the same. This remains as 9. This is originally over 1. So I multiply this by 3 to the x. I multiply this by 3 to the x. So yeah, I actually get 3 times 8 times 3 to the x. Right? And then here, I'm going to get 3 to the x times 3 to the x. So now remember how when we in an equation and our denominators are the same, they fall away. So I get 9 plus 8 times 3 to the x is equal to, this is the same basis, it's 3 to the 2x actually. I understand step 2. Are you talking about this step or this step? Step 2 or 3? Okay, so let's revisit step 3. So basically, I'm doing LCD. I'm doing lowest common denominator. That's what I'm doing. And the lowest common denominator in this case is they all over the power of 1. 8 over 1, 3 to the power of x over 1, because they're not written as fractions, and any number can be written as a fraction when you divide by 1. So in this case, the lowest common denominator is actually 3 to the x, because what can go into lowest common denominator, lowest common multiple? What's the lowest multiple of 3 to the x? 1 and 1. It has to be 3 to the x, because 1 can go into any number. So this is over 3 to the x plus over 3 to the x. So I make it all 3 to the x. And what I then do is I multiply. How did I get from this old denominator to the new one? It's the same thing. It's like multiplying by 1. So this stays as 9. How did I get from 1 to the new denominator? I had to have multiplied by 3 to the x. So I do the same to the top. How did I get from 1 to 3 to the x? I multiplied by 3 to the x. So I do the same on top. So 3 to the x times 3 to the x, the bases are the same, and then in multiplication, we add the exponents. We left with 3 to the 2x. So I'm going to bring everything all over. I'm going to take it over to the other side. You're going to have 3 to the 2x minus 8 times 3 to the x minus 9. How do we solve this? Okay, so I'm going to teach you the most basic way. Not the most basic way, but the best way to solve it. It's something called K method. Okay. Okay. So K method is basically when you replace something complicated with just K. Okay. So there's something that's complicated. Like, let's look at this, right? We have 3 to the 2x minus 8 times 3 to the x minus 9. It somewhat seems like a trinomial because yeah, I have a squared or like a 2x. Yeah, I have an x, and yeah, I have a constant. And that's exactly what it is, right? So what is the complicated part is this guy, 3 to the x. So what I'm going to say is I'm going to say let 3 to the power of x equal to k. So this way I can solve now trinomially, okay? So wherever I have 3 to the x, I'm going to replace it with k. What about 3 to the 2x? Remember, 3 to the 2x is basically like 3 to the x squared. So I can replace, if I say let 3 to the x equal to k, it's going to become k squared minus 8 times k minus 9. Ooh, that's looking a bit more friendly. Okay, so now I can factorize this guy. Minus 9 plus 1. K is equal to 9, or k is equal to minus 1. Now that I've solved for k, remember, okay, k we equated to 3x, 3 to the power of x. So now we're going to say 3 to the power of x is equal to k is equal to 9, or 3 to the power of x is equal to negative 1. This exponent cannot give you a negative, so this we ignore. Okay, that solution doesn't work. However, 3 to the x can be written as, 9 can be written as 3 to the 2. Bases drop, and we have x is equal to 2. Okay, so K method. Oh, that makes sense. Okay, so no questions so far, but I just want to revise it. So yes, we just simplified the equation as much as possible, utilizing our Surds knowledge. So like here, for example, we wrote it out to that. Then we wrote it out like this, and we realized we have a denominator, so we need to get a common denominator for all three, which was 3 to the power of x. Once we simplified, we were left with that. 3 to the power of 2x minus 8 times 3 to the x minus 9. Okay, and in that case, whenever you identify this complicated term that doesn't look like, you can take a trinomial, you use K method. So whatever the complicated term is, yes, the notes will be sent to the group, correct. Whatever the complicated term is, you replace it with K, and then you can substitute accordingly. So again, how did I get K squared? Like that. Okay, and then you factorize, and then you solve for it. Let's just have a look at some examples. I think we can do this one. This one. This one, if we have enough time. Okay, sorry, just give me 2 minutes. I just need to go to the bathroom. I'll be back shortly. Okay, sorry about that. I'm back. Okay, so we're just going to finish these last 3 examples and then we will conclude there. And then next week, we're going to start with trigonometry. Okay, so let's have a look. We have this example. So how are we going to solve this example? Let us see. Okay, so what we can do is, firstly, again, our first reaction is to always break these down, right? So no matter what we have here, we just want to separate them. Even the 4 to the x, right? I can change that to 2 to the 2x, okay? Or alternatively 2 to the 2 to the x, which then simplifies to 2 to the 2x. Okay, so we want to simplify our bases as much as possible. Can't see screen properly, I would refresh if I was you. Okay, so let's have a look. Let's do this example, right? So what I'm going to do is I'm going to have 2 to the 2x times 2 to the 1. Maybe let's do this. Two to the 2x times 2 to the 1 minus 3 times 2 to the 2x times 2 to the minus 1 plus 2 to the 2x, because that's what 4 to the x is equal to 12. Okay, so this is how I simplified it. I hope that everyone understands how I got here. Okay, 2 to the x. Remember, this came from 2 to the 2x plus 1. Then we add minus 3, open brackets, 2x minus 1 plus 4x. Okay, this is how I got here. Okay, I'm separating each one. Now, if you have a keen eye, you'll notice that in each term, there is something common, 2 to the 2x. That is known as my common factor. If 2 to the 2x is my common factor, what am I left with? I'm left with 2 to the 1, which is basically 2 in that term. Okay, minus 3 times 2 to the minus 1 plus, remember, when you take a common factor, it's like dividing by the common factor. So when you divide by itself, you're left with 1, basically, is equal to 12. So now 2 to the 2x, right? What I can do is I can leave this alone. Now it's like 2 to the 2x times everything in this bracket. So let's simplify everything in this bracket. You can use your calculator again. That shouldn't be an issue. 3 times 2 to the minus 1 plus 1. So basically it's 2 to the 2x. And in here is 3 over 2 is equal to 12. Now 3 over 2 is multiplied by 2 to the 2x. So when I take it over, I can divide. So I can say 12 over 3 over 2. And when I do that, I get 8. So 2 to the 2x is equal to 8. Now my unknown is an exponent. So when the exponent is unknown, I want to get same bases. So I just say 8 equals shift fact. So I get 2 to the 2x is equal to 2 to the 3. Drop the bases. And I get 2x is equal to 3. X is equal to 3 over 2. Again, these examples look complicated, but once you break them down, they're not so bad. Let's do another one. Same concept. I'm going to break this up. 2 to the x times 2 to the 1 minus 2 times, how can I break up 4? 4 is 2 to the 2x, which is equal to 2 to the power of 2x. So 2 times 2 to the power of 2x over 3 times 2 to the x, that's simple, simplified already, times 2 to the 2x. How many marks is this question? 4 marks. Okay, so what you'll notice is on top, I can take a common factor of 2. Okay, So once I take my common factor of 2, at the bottom, I'm left with 3 times 2 to the x minus 2 to the 2x over, at the bottom, I still have 3 to the 2x minus 2 to the 2x. So now we can see that Ian and 2 here, that's dezelfde. These two are the same, 1 and 2, these are the same. Okay, so when they're the same in multiplication, remember it's 2 times this entire bracket. I cannot cancel across a negative generally, but if I'm canceling the whole term, then I can cross. And then I'm just left with this entire thing equal to 2. Okay, let's do the last example we set out to do. Number 4. Okay, so again, I'm going to split the bases. In fact, I'm going to split 9 as, maybe let's do that later. So 9 to the x times 9 squared minus 3 to the 2x. Okay, divided by 3 to the x times 2 to the 3. And that's supposed to be 8. That's certain as 2 to the 3. That's fine. Times 3 to the x times 5. So now the 9s I can simplify as, so it's like 3 to the 2 to the power of x, which is 3 to the 2x. So 3 to the 2x, and then 3 to the 2 to the 2 again. So it's like 3 to the 4. Minus 3 2x over 3 to the x times 2 to the 3 times 3 to the x. Okay, by the way, 3 to the x, I can simplify this. 3 to the x plus 3 to the x. These are like same bases, different exponents in multiplication. So x plus x is 2x. So that's how I got that one, okay? Times, okay, let's take it step by step. We can write it as 3 to the x plus x times 2 to the 3, simplest third form, times 5, right? Then I can see, right, on top, there's a common term, there's a common factor in both terms. I can take on top a common factor of 3 to the 2x, and I'm left with 3 to the 4 minus, when I say 3 to the 2x over 3 to the 2x, I'm left with 1. At the bottom, 3 to the x plus x is 3 to the 2x times 2 to the 3 times 5. Now it's in multiplication with this bracket. Everything at the bottom is multiplication. I can cancel these two out, and I can just simplify the numbers. So this is 81 minus 1, I think is 80 on top. 8 times 5 is 40. And your final answer here is 2. Pretty sure at least. Can you take 3? Okay, so you can potentially take 3x. Okay, so in that case, you could, okay, if you take 3 to the power of x, that's fine, but then you would rather just have it separated. 3 to the 2 times 3 to the x times 3 to the 4, it's just a lot more. 3 to the 2 times 3 to the x. Then you take 3 to the x as a common factor, you're left with 3 to the 2 times 3 to the 4 minus 3 to the 2. But you see, there's still that 3 to the 2 that you can still take further as a common factor, but it doesn't matter because you can then simplify the numbers. So yes, you can take 3 to the x as a common factor and then simplify from there. Okay, let's do, if you guys don't mind to stay a little bit extra, let's just do this one and do this one. Okay, so firstly on top, if you're going to try and put this in your calculator, it's not going to give you anything, right? Your calculator doesn't have enough memory to calculate the value of 3 to the power of 2020, because it's like 3 times 3 times 3 times 3 times 3 times 3 times 3, 2020 times, okay? So what we're going to do here is we're going to take a common factor, actually, okay? So for now, we're just going to work between this. So what you want to do is you're always going to take a common factor of your lowest power. So if I look at 2020 and 2018, okay, and 2018, you're going to take your lowest power in general from top and on bottom, okay, on all the terms. So if I look between these terms with the high powers, the lowest power is 2018. So I can take a common factor of 3 to the 2018. When I take a common factor of 3 to the 2018, here I'm left with 2020 minus 2018. And here I'm left with 3 to the 2, and there I'm left with 1. Plus 8 divided by 3 to the 2018 plus 1. I simplify further. I have 3 to the 2018. This is 3 squared is 9, minus 1 is 8. So basically, I have 8 times that. So 8 times 3 to the 2018 plus 8 divided by 3 to the 2018 plus 1. Now I can see that on top, I can take a common factor of 8. And I have 3 to the 2018 plus, what am I left with? 1 divided by 3 to the 2018 plus 1. This cancels with that, and you're left with 8. Okay, let's do the third one quickly. So with the surd, you want to do the exact same thing. Okay, with the surd, you want to take a common factor of the lowest power as well. Okay, and you can, right? So what you want to do is your surd is going to be, your common factor, sorry, is going to be a surd common factor because, okay, I'll explain it now. So I'm going to take the lowest power. So 7 to the 198 is the lowest power from all of these. You're going to look at your denominator and your numerator. Whichever is the lowest power, you're going to take the common factor of that. And I'm left with, when I take the common factor of that, I'm left with surd 7 to the 198. The difference between 198 and 201 is 3. Okay, minus the square root of 7 to the 2 goes 200 minus that. Okay, at the bottom, I'm taking the same common factor, 7 to the 198. And what am I left with? Square root 7 to the 1 minus, in this case, just 1, because that is the common factor itself. Okay, then let's continue. So here, this cancels with that. And I'm left with, this is 7 to the 3 over 2 minus, that cancels with that, that's just 7. Square root 7 minus 1. Square root 7 can be written as 7 to the half minus 1. You can probably just put this in your calculator and simplify. So if you want to simplify the top separately, 7 to the 3 over 2 minus 7. Okay, when you actually simplify it, you get 7. Put in your calculator, or alternatively, like you can do it as 7 to the 1 and then take the common factor and blah, 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 but this is fine. Yes, correct. When it has 7a squared, when the 7 has a squared, then it automatically cancels the surface, the surd, because it's 7 only is left with only. Yes, so yeah, if it's squared, you must remember the square root of something squared is that thing. Like, what's the square root of 8 squared? It's 8. Because it's like the square root of 16, which we know is 8. You know, so what's the square root of a squared? That's 8. Okay, cool. So the last examples, I've done some hard examples, which may be a bit unnecessary, but it's fine. I just wanted to finish some Surd questions, and I did some basic questions as well. So you guys can go through this document, do as much as you can. And there's some like really simple examples you could practice here, right? Just for your own practice, and then go through several examples here, all following the same concept, all right? So yeah, so the next time I'll be seeing you guys is next week, and we will be doing trigonometry. We're going to start off with trigonometry, right? So I think I mentioned to you guys the document with the order of the topics that we're going to be doing. So please make sure to go through that, and then you'll see for next term and third term and fourth term, which is the order of the topics we're going to be doing. This document will be uploaded to the Google Drive. The link for the Google Drive is found in the description of the group. Okay. I don't know if I told you guys, but yeah, anyone who's joining, please make sure that they are aware, or if you guys need to be aware, the Zoom link is always found in the description of the group. You don't need to get it each time. It's not a new one. But yeah, okay, cool. Thank you guys so much for joining. Okay. I wish you guys a good week at school. Exams are starting soon. When will the playlist be uploaded? The playlists are already uploaded. The playlist, the link for the playlist can be found in the description of the group. All the videos are in there. Okay. Okay, thank you guys so much. Will we do exam revisions? Yes, if we finish the topic, we will definitely have a lesson for exam revisions. Okay, when are you guys writing maths? Could you please give me a date? Just like whoever, just Wednesday. Wednesday. 10th. 15th. Hey, look, so those who are writing Wednesday, unfortunately, we weren't able to cover trigonometry before you guys started. Those who are writing after, fortunately, we will cover trigonometry. Hopefully, going into second term, we'll be able to be a lot faster, because we will start a lot, obviously, on time, and we will work as we go. And then hopefully we'll have time for exam revisions in term 2. But yeah, cool. Thank you guys so much for joining. Again, have a good week. Okay, Jazakallah khair. Assalamu alaikum and goodbye.